Yeah, hello everyone. Today, briefly, I want to speak a bit about observability and where we're headed, because I believe observability per se, so being able to monitor our systems and ask questions, is not really the final goal. It's a starting point on a journey, and there are a couple of things that come out of it. This is an ongoing discussion. You're just getting my take on it: observability versus monitoring. My point is we really actually need both. There's a lot of discussions, and sometimes you hear people saying that, well, observability is great, it's actually replacing monitoring, and we should move to observability from traditional monitoring. I think the story is a bit more complicated than that. If you look at what monitoring can do for you, first you monitor well-defined metrics, which is super helpful, which is still what a lot of people want to use. They're typically ones: response times, error rate, load, and so forth. You define errors on those metrics very often because you understand them well and you know how to define, you define alerts on them because you know how to understand them, or you have a system learn how to have errors defined on them, obviously using anomaly detection. And then you can build, obviously, pre-built dashboards, because the only way you can build pre-built dashboards is if you know what you want to put on them. Why this is important? Because this approach actually scales very well for larger organizations. So if you really roll out monitoring to a lot of teams, which microservice architectures kind of force us to do, if we have hundreds of teams and we want to have a consistent picture, we build everything on a consistent basis. And we know that we understand somebody else's system when we look in it. And last but not least, they're great for operations teams. So if you have to train an operations team on applications, you want to have some standardization, what they're looking for, and for fault isolation. We had it today in calls before where we talked about root cause analysis and finding what the problem is to fix and how to remediate. Also, we at Dynatrace differentiate between fault isolation, knowing which component is actually broken, versus then doing the root cause analysis, so figuring out what the exact reason for something that is broken is. And last but not least, once you build automation on top of your problems, this is also what you can do well on monitoring data, because it's a clearly defined set of data. And you say if certain situations happen, you monitor those, you want to counteract by scaling up, by rebooting, and so forth. So that's what monitoring is great for. Now let's look at observability. Observability is often referred to as monitoring the unknown. So let's put it that way. It's monitoring or looking at all the other metrics in your environment that are not part of your core monitoring strategy, that's part of your fault domain isolation. What you want to do is you want to provide flexible, multi-dimensional analysis of the data, so you want to ask it questions. That's technically what you do. You have tags, you have dimensions, and cardinality. So sometimes it's just called multi-cardinality, while it's also multi-dimensional. And you want to provide a flexible data visualization. Based on the questions you ask, you want to look at the data in different ways. This is great, but this is also a totally different use case, and I think that's the important piece here. It's great for ad hoc analysis. It's great for SREs when they want to go into root cause analysis. It's great for capacity planning. It's also great for if you run a what-if analysis. So that's the key bits and pieces that you want to look into. And I think you need actually both. You need the monitoring side and the observability side in the system. There's often this talk about unknown unknowns. If we talk about unknown unknowns, we obviously only talk about humans, because you can't expect to ask a system about something that it doesn't know. So unknown unknowns only exist for us as the human user, but not for the system. What this actually means is you have to bring all the information into your system, because otherwise you cannot ask questions about it. So the first thing you have to do, you have to understand have to build a very powerful system or a model in your system that helps you to understand all of the complexity. And what you have here is a model. I'm taking this out of Dynatrace, but technically what we do, we take all the data and put it into a consistent, easily to query model, which in this case is a 5-dimensional data representation. Why is it 5-dimensional? It represents obviously the lower level, the infrastructure. It represents the application level, which is the services, but also the user and business level, like which transaction do certain services belong to. Just looking at a login service won't tell you whether this is a part of, like in Uber example, whether this is currently maybe somebody logging in as a driver or somebody who wants to consume something, and even less, it won't tell you if this is one of your premium customers or other customers. Then the fourth dimension is time. You often forget about time. Very often when people talk about problems, they talk about the problem as a whole, but not how it evolved over time. And the fifth dimension wouldn't be changes that are made to the system over time, because very often changes that happen in the system are the reason for our problems. In order to get all of this data, you can't rely on manual instrumentation, because then you're back to your known knowns. People will only instrument what they know about, and very often they forget something. That's why we believe that having learning agents as part of your infrastructure is key to monitoring. So it means you deploy an agent on the system that automatically detects what is running on these environments and installs all the monitoring automatically that's available. Think of it more as like a big service catalog that would install things automatically rather than relying on a human to install something. Somebody decides to use Redis, ensure that Redis gets automatically monitored. Somebody decides to use a certain AWS service, ensure that it gets monitored. And very often there is nobody in the company who knows about like all of the technologies used in a system. This is just a very small system, and you already see all the different types of technologies that are used in there. So rather you want to have a big catalog of monitoring that's automatically applied and have these adaptive learning agents running on the system that would then automatically do it. Then there's another problem which we need to solve that we unfortunately don't talk enough about, which is human bias and observability. If it's up to us to ask questions, then also the quality of the answers depends on the questions that are asked. And just to give you a couple of examples here, why humans need assistance in analysis, because we are actually, if you look at human bias, and you can Google human bias, then you see how bad we humans are in analyzing data. The first bias that you usually run into, and this is very true especially for performance and problem analysis, is the confirmation bias. So usually we target our analysis to what we already think might be the problem. And a lot of the questions we will be asking a system target towards, okay, we assume it is AWS that's the problem. So we will ask a lot of questions, and the more data, we will look for data that confirms our initial assumption. This, however, might lead in the wrong direction. The next one is selection bias, which kind of goes in place here. So data selection is very often subjectively. So also the data that we pick to do the analysis in the first place, that depends a lot on what we have available or what we are familiar with. So very often we don't query the data that we would need to query. So just having the ability to query doesn't necessarily mean we're querying the right data, because we are trying to test assumptions, or we usually go with the data that we better understand. And then there's overfitting and underfitting, which is also a problem in machine learning. As humans, we usually go for underfitting because we usually prefer the easier solution to a problem. If there seems to be an obvious solution, we are preferring it over a highly complex solution. And the last one is bias is confounding variables. Let me give you an example. People who are using umbrellas are more likely to break their legs than people who don't. This would be a valid study. What did you forget about this? There is a so-called confounding, like third variable in it, which is like it's obviously raining, so people might be slipping on the street. That's why they're wearing an umbrella in the first case, and that's why they might be slipping more often than others. So sometimes we correlate variables together that are not correlated by themselves, but there's a certain forced variable in between, which we forget about. And that's even why a great master Yoda said that humans are very biased. And we have to be aware of this whenever we do data analysis and lead to these results. So what we need our systems to do, systems actually need to help us overcome this bias. And how are they doing this? By actually combining monitoring and observability. So we have monitoring data in here. This is an example of a problem analysis where we have what's the impact, what's the potential root cause, and you also see the dimensions that were analyzed, plus what we call explainable AI, so using AI algorithms that analyze all the data, because once we use algorithms to analyze data, we can analyze everything and overcome a lot of that bias, leading us in the right direction while still keeping this explainability in here and having the system explained back to us. It also helps us to scale because we are simply dealing with a complex problem here. I know that's a funny statement. If you look at this, these are the number of interdependencies that you have in a system. So this is just, I'm taking one service, two services, three services, and providing an order of how these events affect each other. This is where our brains are. That's the lower piece. And this is a logarithmic scale, by the way. So actually that scale in reality looks more like this. So you see that there is like this breaking point at the very end where it's totally impossible for a human to analyze it. Unfortunately, we talk about microservices that have way more events that come together where we have to build in some type of observability in there. So we are good at analyzing small amounts of data. However, what we have to do is analyze these very high amounts of data here. And just to give you a very simple example here, I'm taking an example real-world problem that I usually apply for problem analysis, which is this one here. I'm showing this problem to people, which you don't see right now because I'm still in presentation mode. And here we go. So you see a problem here, and this is the front-end errors that you would see. Unexpected end of input, cannot set property of undefined, something like this. Usually this would result in a front-end problem because this is obviously a front-end problem because these are all JavaScript error and somebody forgot to include something in this analysis. So you would go to your front-end team. You would tell them what they did wrong and what they deployed yesterday. They might come back to you now telling you that they did not deploy anything yesterday. Or even worse, they would tell you that they deployed something yesterday and you would look for an error. The interesting thing here, however, is when you look back into the actual problem, and this is what I mean by AI assisted, that it will tell you that the problem lies actually somewhere completely different and gives you the reason for this actual failure. And the reason in this case was that your CouchDB was failing. Your CouchDB was failing because there was an error in the configuration of CouchDB which resulted in CouchDB crashing and not returning any JavaScript anymore to the front end, which obviously resulted in the front end that a lot of JavaScript variables that were relying on JavaScript to be broken. So this is a very simple problem that already shows you how bias is actually putting us into a situation where we as humans take the wrong decision and follow all of these practices. And just take this as some feedback, how often this might happen in your situations where you would go for that simple problem versus that complex problem. And that's why I think having this combination of both observability data, but at the same time a layer of analysis on top that allows us to go in there and analyze these problems on top is where we have to really go next and ensure that we have this as a basis for the analysis we're doing and don't just rely on query interfaces per se. Obviously, as this was a sponsored talk, I have to remind you that Dynatrace obviously has a booth here and you can stop by and learn more about this and see what we're doing. Thank you.
Yeah, give it up for Alois.